means if you will write an algorithm, then how you can calculate the time complexity of that specific algorithm. I just gave you the example using linear search and binary search as well. So how you can calculate the time complexity of binary search, that also I have discussed in the previous day class. Today what I'm going to do is, already in the C programming classes you have studied about insertion and deletion in the array, how you can insert a new element in the array, how you can delete a specific element from the array. So this part already you have studied in the previous semester, but since these things are included in your data structure syllabus as well, that's why we will go for that part again. We will repeat that part again. And not only that, what will be the time complexity, that also will be discussed using those algorithms like insertion in the array or deletion from the array. So this part we are going to discuss one after another. First of all of you know that mainly insertion and deletion will be taking place in the one-dimensional array. So in the one-dimensional array, how we can insert a new element in the array, that is the main thing we are going to discuss. So suppose we have this array. Suppose the elements are 10, 5, 35, 12, 7, 22 and 2. A random array is there. So when we are going to take this random array and we are going to insert a new element in the array, suppose these are the index values 0, 1, 2, 3, 4, 5, 6. These are the index values that are present. Now when you are going to insert a new element in the array, suppose you are going to insert the new element, that is 15. 15 is the new element, that is our key value that we want to insert. When this insertion is going to be taking place, you need to understand that how this insertion is going to be done. To insert this particular element in this array, first you need to know in which position you want to insert that value. Okay, that position value or that position you need to know. Suppose the question has been made in third position. In third position, you have to insert this value 15 in this particular array. Third position means, when position will be signifies, position means index plus 1. Index plus 1 will signify position. Why? Because array index start, suppose this is the array ARR, array index starts from 0, but 0th index means first position. So first position, second position, third position. So third position means index value is 2. So if the question will be made like in third index, then different thing will happen. But if the question will be made in third position, then you have to understand third position means in index number 2 you have to add this new element. Suppose the question is there that in the third position insert this particular element 15 in that array. When you are going to perform this operation, then what will be the logic of performing this operation? The logic is simply, you have to make this room empty so that you can easily insert 15 over there. But the problem is you cannot hamper the already existing element present in the array. You cannot hamper that. Those elements which are already present in the array will remain as it is. It will not be modified. But what we have to do, a new element, a new key value will be inserted in the array. So to do that thing, what we are going to do, normally if this is a dynamic array using malloc function, if you have assigned this array, then the problem is, since you have assigned this array using malloc function, no extra memory spaces are there to the right hand side. Okay, so in that scenario you have to use realloc function to reallocate the memory. Why reallocation is required? Because when you are going to empty this particular position, you have to make another space. Why? Because this 2 will be moved over there, this 22 will be moved over there, this 7 will be moved over there, this 12 will be moved over there, and this 35 will be moved over there. So when this movement will be done, then the last element will be moved to the next location. But the problem is, if you are assigning this array using malloc function, then only this size of memory has been allocated. So to insert a new element, the size of the array will increase after the insertion will be done. So that's why you have to reallocate the memory space that you have assigned using this malloc function. What will be the new size? The new size will be previous size plus 1, because one element you are going to insert. Okay, so if you are inserting 3 elements, then you have to perform the new location, new size will be previous size plus 3. So in that way, but normally one element we are inserting in one step, in one execution. So that's why the size will be previous size plus 1. So using realloc function, you have to allocate this array again. So if you are taking static array, this problem will not arise. Why? Because normally the size of static array, you will take a large value. So that's why no problem will arise. Extra spaces are available, so you can easily shift the elements towards right hand side. Okay. Well,
after using realloc function, the elements still exist. The elements
still exist.
Okay.
So basically, in that way, you can easily find the location. So you can easily insert the element. What will be the loop structure? Suppose you have taken static array. So what will be the loop structure? Suppose you have taken static array int error. Suppose the size you have given as 30. So maximum 30 number of elements you can store inside the array. But only 1, 2, 3, 4, 5, 6, 7, 8 number of elements are there. So no problem will arise. Extra spaces are available. When you are going to perform that, first you will take this array input. I am not talking about array input again, because you know how using loop structure you can insert the element in the array. After the insertion will be done, in which position you want to insert, that position value also be given using scanf function. Because user can give third position, user can give fifth position, user can give any number of positions. So that's why this value will also be taken from user. And not only that, which key value you want to insert, that key value will also be given by user. So these value, this position value, this key value, all will be user given values. Remember, when you are going to execute this program in lab, you have to give these values, not static values. You have to give these values from user using scanf function. Okay. After that, what will be the main logic part? We need a loop structure. Why loop structure is required? Because this shifting we have to perform. So for that, I have taken a loop variable. Loop variable aage assign kore dibi. Ami program to dekhachi. I'm just talking about the logic part. So for I equals to n minus 1, where n is the number of element present in the array. So I equals to n minus 1. Why n minus 1? Because if the number of element is 7, 1, 2, 3, 4, 5, 6, 7, eta to extra 7, then the last index is n minus 1, that is 7 minus 1 means 6. So that's why I have written for I equals to n minus 1, I greater than equals to position I minus minus. Why minus minus will be encountered? Because when this shifting will be done, we have to move towards left hand side. When left hand side movement is there, the I value will decrease to the left hand side. So we have started from rightmost and we are moving to the left hand side. That's why I minus minus has been encountered. When this part will be there, what we are actually doing? We are writing ARR of I plus 1 is equals to ARR of I. That means initially I is equals to n minus 1. When I is equals to n minus 1, n minus 1 plus 1, that means n. N means this part, 7. N value is 7. So this part in this index, which value will be copied? The previous value will be copied in this index. So 22 will be, age 2 chilo ekhane, that 2 will be copied in this particular index. When 2 copy of the same number will be there, then you can easily modify this copy with the previous value. So that previous value will be inserted in the next position. That's why error of I plus 1 is equals to error of I. And how many times this operation is going to be there? Until and unless je position e toke insert korte boleche, in our example we have to insert it in the third position. Tale third position er value ta jotokhon na tar porer position e jacche, so until and unless the I value will not be equals to that position value. If third position means obviously index is 2, so until and unless this part will not be there, sorry, I have written position, sorry, position minus 1, sorry, because position is third, but you have to do up to 2 index. Third position means up to 2 index, because third position means index is 2. So up to position minus 1 you have to do this operations, so that this shifting is going to be done. After this shifting will be completed, what you are going to do at last, outside the for loop, you are writing error of position minus 1 is equals to our key value. That means in this particular position now you are inserting the value 15. So we can say that the insertion has been done. What you have to do right now after this operation will be done, you can see previously the size of the array was n, but now after insertion the size of the array has been increased by 1, that is now it has become n plus 1. আগে n ছিল মানে 7 ছিল, যেই আমি এটাকে ইনসার্ট করলাম, এগুলোকে শিফট করালাম, একটা সাইজ বাড়লো, 8 হয়ে গেল the size of the array. So that means when you are going to print this array, you have to write the loop structure like for I equals to 0, I less than n plus 1, সেটাও লিখতে পারো, বা I less than equals to n. আগে কি করছিলে, I less than n লিখছিলে because n minus 1 অবধি যাচ্ছিল. Now it will goes up to n, so I less than equals to n, I plus plus, then you will print the array like printf percentage d, you will print the array. I'm not writing this part. So this is the total structure by which you can insert the element present in the array in a specific position. Now if we are talking about the time complexity of this specific algorithm, then what will be the time complexity of that specific algorithm? 3 cases will come in this scene. First one is best case, second one is worst case, third one is average case. So you know that these are the basic 3 cases that will come in the scene when we are talking about a specific algorithm time complexity analysis. You will tell me that what will be the best case time complexity of this particular algorithm, that means inserting a new element in a specific position.
जब लास्ट पे इंसर्ट करेंगे,
right? So that means when we are going to insert the element at last, how many number of shifting will be required? How many number of shifting will be required if the position value is equals to n minus 1?
no shifting.
একটাও শিফট হবে না?
one
every time shift will done.
হ্যাঁ, না যদি একদম লাস্টে করি, একদম লাস্টে করি তাহলে কি কোনো শিফটিং দরকার হবে সেটা ভাব।
দরকার পড়ছে না, দরকার পড়ছে না তখন।
So that means if at last we want to insert this, then it will not require any shifting. হ্যাঁ, তোমার যদি লাস্টের আগেরটাই হতো তাহলে একটা শিফটিং করলেই লাস্টের আগেরটাই হয়ে যেত। But the problem is if you are going to insert the new element at last, then no more shifting will be there. That means this loop iteration is actually not required. So in that scenario, what you can do, you can easily say what is the best case time complexity of this particular algorithm. Tell me. Big of
Big of 1 or
big
0?
of 1, right?
1 ही तो अच्छा.
So basically it will be taking constant time, because mainly the shift, for this shifting actually the complexity matters, because only this loop is mainly the execution loop. Amar printing ba input newa loop ami bar bar bolechi, it will not be considered in the case of complexity analysis. Only the main logic part, the loop structure, will be considered in the crime complexity analysis. So it will be in the best case it will be big of 1. In the worst case scenario, what will be the time complexity? Tell me, you can say.
Big of n.
Big of n, of course, because if you want to insert the new element at the first position, then lots and n number of movements are actually required. তোমাকে বললো ধরো position first, তার মানে index 0. index 0 তে তোমাকে যদি ইনসার্ট করতে হয়, তোমাকে যতগুলো নাম্বার অফ এলিমেন্ট আছে অ্যারেতে সবগুলোকে মুভ করাতে হবে, and you have to make this space empty. So that means the number of times this loop is going to be iterated is n. So that's why it is big of n time complexity. What will be the average case time complexity? ধর মাঝখানে বললো, তাহলে average case time complexity কত হবে বল?
Big of n.
Big of n. কেন? কারণ big of n by মানে n by 2 ও যদি হয়, n by 2 times ও যদি লুপটা ইটারেট করে, if n is equals to n by 2, that means half into n, then also it will be big of n, because ultimately this is the main function which constant value is multiplied. That does not matter at all. Okay, so that's why in average case and worst case all will be taking big of n complexity, but in the best case scenario the loop will not iterate, so that's why the time complexity will be big of 1. Now similarly, all of you know that how you can delete a specific element from the array. So in that way you can calculate the time complexity of deletion as well. আমি deletionটা বলছি না, তোমরা ল্যাবে করবে how you can delete a specific element from the array, and accordingly you have to calculate the time complexity. The time complexity is same like insertion. If you are going to delete the last element, then no shifting will be there, so that's why you will taking order of 1 time complexity. But if you are going to delete the first element, lots and lots of shifting will be there, n number of shifting will be required. So in that scenario n minus 1 number of shifting, একটা তো কমে যাচ্ছে, n minus 1 number of shifting will be there, but ultimately it will be big of n. n minus 1 হলেও সেটা big of n, n plus 1 হলেও that is also big of n. So you can understand what will be the time complexity of insertion and deletion in the one-dimensional array. Now the next thing that I am going to talk about is polynomial addition using array. Mainly polynomial addition part I am going to discuss. Polynomial addition using array. What is the polynomial concept? Suppose you have a first polynomial p1 is equals to 3x to the power 4 plus 5x square plus 2. This is the first polynomial. And we have another polynomial 2x to the power 5 plus 3x square plus 9x. Okay, so any power we can use, because you know the degree of the polynomial can be maximum n, so that n value you can take according to your choice. The degree of this polynomial is 4, the degree of this polynomial is 5. That means the maximum power present in the term in a polynomial expression can be considered as the degree of that polynomial. Here it is 4 and here it is 5. Now when we are going to perform the polynomial addition, then how we can perform the polynomial addition with the concept of array. You will study polynomial addition with the concept of linked list also later on, when we will study about linked list. Then again we will go for that part using linked list. But now since we are talking about array, you need to know that how using array concept we can perform this polynomial addition. The concept of polynomial addition is, what is the polynomial addition concept? The polynomial addition concept is, when you are going to add this to polynomial, first you have to compare this degree value, that is the power value. If the power value is equal, then the coefficient will be added. If the power value is not equal, then the coefficient is not going to be added. It will be separately present in the resultant polynomial. And you know that after adding two polynomial, another polynomial will be created. Okay. So if we are going to add this to polynomial, the resultant value will be 2x to the power 5 plus 3x to the power 4 plus 8x square plus 9x plus 2. So this is the resultant polynomial. After polynomial addition will be performed. Okay. Now, when you are going to perform this operation using array concept, what will be the concept of this particular polynomial addition? Basically, there are lots of ways by which you can solve that thing, but the simple way to do that thing is using array of structure. Why structure is required? Because you can see in a specific, first of all, forget this addition. First of all, what is your main task? The first task is you have to represent this polynomial using array. You have to represent this polynomial using array. So first represent the two polynomials using array, then perform the addition operation. But the problem is, you can see that there are two terms that are associated. There are two parts that are associated with each and every term present in the polynomial. What are the parts? First one is coefficient and second one is exponent. So coefficient and exponent, these two parts has been associated with each and every term of the polynomial. आगे तो हमें polynomial दुटो represent करते होबे, then we can go for addition operation on the polynomial. So that's why we can take a simple structure. Struct, suppose the name of the structure I am giving as polynomial. So poly. So first of all int, আমি ধরে নিচ্ছি এটা ইন্টিজারই নেব। তোরা যদি float নিতে চাস floatও নিতে পারিস, float ই নে। কেউ তো 3.5ও নিতে পারে। Float coefficient and exponent value will be always integer, this exponent value. So exponent. So this is the structure of the polynomial terms. For each and every term, we are taking a polynomial structure where two parts will be associated. First one is coefficient part and second one is exponent part. Okay. Now, when we are going to add two polynomials, you have to remember that for adding the two polynomial, we need this particular. That means when this term will be associated, you need this structure. When this term will be associated, you need this structure. When this term will be associated, 2 means it can be written as 2x to the power 0. So 2x to the power 0 means x to the power 0 means 1. So we can represent that value. Okay. Now, when we are going to signify this thing, then we need this structure type array. Until and unless you will not represent a structure type array, you cannot represent this thing. Why? Because this is one structure, this is one structure, this is one structure. Multiple same type of structures are there, so you need the help of structure type array. এবার অ্যারেটা তুমি ডাইনামিক নিতে পারো, তুমি স্ট্যাটিক নিতে পারো, আমি স্ট্যাটিক দিয়েই দেখাচ্ছি। So after taking this polynomial, struct polynomial, what I am going to do, I am going to write the main function. আমি মেনের মধ্যেই পুরোটা লিখছি, তোমরা পরে আলাদা ফাংশন দিয়ে সেপারেট করে করবে। Inside the main function, what you are going to do, you are going to first write that arrays are required. So which type of array is required? Struct polynomial type of array is required. So I am taking struct polynomial suppose the first array I have taken as আমি ধরে নিলাম ম্যাক্সিমাম আমি 20টা টার্ম দিতে পারবো 20 আমাকে তো একটা ম্যাক্সিমাম সাইজ দিতে হবে, so that's why I have taken this 20 value. After that, when you are going to perform this operation, you need to know that you need another array, and this array is for first polynomial representation, this array is for second polynomial representation. So if first polynomial and second polynomial have the size, maximum size as 20, then you should take the third polynomial size at least some more, because the size of this polynomial can be more. That's why I'm taking those 40. এটা 20 তো আমি সাইজ নেব না, আমি জাস্ট নেওয়ার জন্য, বাট সি এর সাইজটা একটু বেশি নিতে হবে, বিকজ হতেই পারে এর টার্মের পাওয়ার গুলো আর টার্মের পাওয়ার গুলো সবই আলাদা। তাহলে এখানে যতগুলো টার্ম আছে আর এখানে যতগুলো আছে সবগুলো মিলিয়ে আমার লাস্ট পলিনোমিয়ালটা তৈরি হবে আফটার অ্যাডিশন, বিকজ নো কমন টার্মস আর দেয়ার। ওকে, সো দিস ইজ দ্য polynomials that we have taken. After taking this polynomial, then what will be the structure or what will be the concept how you can take terms? তোমার অনেক ভাবে তুমি ইনপুট দিতে পারো, there are lots of ways by which you can take this input. সিম্পল ওয়ে হচ্ছে তুমি বলবে যে হাইয়েস্ট টার্মটা সবসময় কি করা হয়, হাইয়েস্ট টার্ম তুমি কতটা নিতে চাও, what will be the highest term that you want to take, that part you will give. বললি আমি ফোর্থ টার্ম নিতে চাই, তাহলে ফোর্থ টার্ম যদি তুই নিতে চাস, তাহলে তুই যদি ফোর্থ টার্ম নিতে চাস, তাহলে তুই ধর এই মানে এই ফার্স্ট পলিনোমিয়ালের ডিগ্রির ভ্যালু তুই 4 দিলি ফ্রম ইউজার ইউজিং scanf ফাংশন। তাহলে আমি লিখলাম enter of that highest degree of the first polynomial, highest degree of the first polynomial, then scanf দিয়ে তুই ডিগ্রির ভ্যালুটা নিলি। তাহলে তোর সুবিধাটা কি হবে, তুই ওই ডিগ্রি অবধি লুপ চালাতে পারবি, ফর i equals to 0, i less than equals to that degree, i plus plus। তাহলে কি সিগনিফাই করবে, তুই ফার্স্ট যে ভ্যালুটা নিচ্ছি that corresponds to 0th degree। যদি তুই সেটার ভ্যালু 0 নিস, তার মানে 0th ডিগ্রিতে তুই কিছু টার্ম দিচ্ছিস না। তুই পরের টার্মটা যদি নিস 5, তার মানে তুই 1th ডিগ্রিতে 5 নিচ্ছিস কোএফিসিয়েন্টের ভ্যালুটা। So that's why that will be the easiest way to increase or to define that polynomial value. আমি একটা দেখাই তাহলে তোদের ক্লিয়ার হবে। ফার্স্ট হোয়াট আই এম রাইটিং, printf, এখানে আগে int degree বলে একটা ভেরিয়েবল নিলাম। হোয়াট ইজ দ্য পারপাস অফ টেকিং দিস ডিগ্রি ভ্যালু আই এম টকিং অ্যাবাউট। সো ফার্স্ট printf enter highest degree of polynomial 1, enter highest degree of polynomial 1, মানে ফার্স্ট পলিনোমিয়ালের হাইয়েস্ট ডিগ্রি তুই কত চাইছিস সেটা তুই ইউজার থেকে নিবি। সো scanf %d ampersand ডিগ্রি 1 বলে নি, তাহলে সুবিধা হবে, আর একটা ডিগ্রি 2 নিতে হবে ফর সেকেন্ড পলিনোমিয়াল। সো what we are going to do, we are taking a loop structure for I equals to 0, I less than equals to degree 1, I plus plus। হায়ার ডিগ্রি যদি 4 নিস, তাহলে এটা তো 4 বার ঘুরবে। এবার ও তোকে জিজ্ঞেস করবে যে তুমি কোএফিসিয়েন্ট ভ্যালুটা ইনপুটে আন। সো ফার্স্ট ইট উইল বি টেকিং অ্যাজ, এখানে লিখি printf enter coefficient, পুরোটা লিখছি enter coefficient। ওকে, scanf দিয়ে ইনপুট নিতে হবে, তাহলে আমি নিলাম scanf % d comma ampersand a of I dot coefficient। কেন? কারণ যখনই আমি এটা নিয়েছি, I have taken that part, that means there is an array of structure variable, That means when this part will be signifies in this is the first element a of 0, this is the second element a of 1, but all elements are not normal elements, they are structured variables. So inside this part, two divisions are there. First one is coefficient, second exponent. Here also two parts are there. First one is coefficient, second one is exponent. So in that way, in each every index, two parts are there because they are normal array variables or not normal array. They are structure type array. So that's all members present in this array are structure variables. Two parts are associated. এবার আমি কি চাইছি a of I মানে a of 0 coefficient enter করলাম, তাহলে enter coefficient a of I dot coefficient. Coefficient has been entered. And আমি কি করতে হবে? What will be the next task that we have to do? We have to exponent value also. So in that case, what we are going to do, we are going to a of I dot exponent equals to that I value. যে I এর ভ্যালুটা আমি দিতে চাইছি সেই I এর ভ্যালুটা আমি a dot exponent এ দিচ্ছি, কারণ I টা যদি 0 হয় that means exponent is 0, I যদি 1 হয় means exponent is 1. এবার তুই যদি চাস তেমন এইটার ক্ষেত্রে কিভাবে তুই ইনপুটটা নিবি, তুই ফার্স্টে দিলি 4, that is the maximum degree, তাহলে তুই প্রথমে তো এন্টার কোএফিশিয়েন্ট, তার মানে 4 এর কোএফিশিয়েন্টটা নয়, তোকে চাইছে 0, 0 থেকে যেহেতু স্টার্ট হচ্ছে তাহলে তোর 0 এর কোএফিশিয়েন্টটা চাইছে where the degree is 0 when I is equals to 0. তাহলে এন্টার কোএফিশিয়েন্ট বললো 0 এর কোএফিশিয়েন্টটা কত আছে 2, তাহলে তুই 2 দিলি a of I মানে a of 0 এক্সপোনেন্টে 0টা বসলো, তার মানে 0 এর কোএফিশিয়েন্ট হচ্ছে 0। ভালো কথা, I plus plus will be encountered. Now the value of I is 1. When the value of I is 1, তুই কিছু চাইছিস না, দেখ এখানে 1 এর কিন্তু কিছু নেই, তাহলে তুই কোএফিশিয়েন্ট ভ্যালুটা কি দিলি 0 দিলি, আর এক্সপোনেন্ট ভ্যালুটা যদি 1 ও হয় 0 into 1 মানে তো মাল্টিপ্লাই করলে সেই 0ই হয়, তার মানে আমার এই টার্মটা নেই। If the coefficient value is 0, that means that term is not present in that particular polynomial. Coefficient 0 দিলাম মানে আমি সেই ভ্যালুটা দিলাম না। Next I plus plus means I value is 2. When I value is 2, I am taking the coefficient value as 5. So 5 আর 2টা চলে গেল। When I value is 3, again I am taking the coefficient part as 0. কারণ এর কোনো পার্টও এখানে রাখতে চাইছি না। But when the I value is 4, now the coefficient value is 3. So in that way, you can insert different type of coefficient values and you can create this polynomial using this structure. So using this array of structure, you have created this first polynomial. Similarly, in the same way, what you can do, you have to take the second polynomial. তার জন্য আমি degree 2 নিয়েছি, তাহলে আমি এখানে লিখেছি same লাইন লিখবো enter highest degree of polynomial 2, scanf percentage d ampersand degree 2 for I equals to 0, I less than equals to degree 2 I plus plus, enter coefficient, scanf percentage d ampersand b of I dot coefficient, b of I dot exponent equals to I. That means in the same way we can perform the execution of coefficient values and we have given these two polynomials. Polynomial করা হয়ে গেছে, so the polynomial insertion has been done. We have created these two polynomials, so the polynomial insertion has been done. What will be your next step? তোমার polynomialটা বলো।
First degree and second degree input taking.
First degree and second degree input taking. Your voice is breaking, Niladri.
X to the power.
Hello.
For x to the power 1, that is coefficient for our taking input.
0. Value will be 0. So 0 multiplied by something means it will not be present actually in the polynomial, right? So you will take the value as 0 because there is no x to the power 1 part, there is no x to the power 3 part. So that's why if you don't want to take that part, just take the coefficient value as 0, because ultimately in an n degree polynomial all the degrees are actually present, but since the coefficient value is 0, that's why this part has been reflected in the polynomial. So just take the coefficient value as 0 if you are not going to take that part.
1 into 0 equal to 0. That part I have not.
1 into
0 you told that 1 into 0.
নীলাদ্রির কথা আমি কিছু বুঝতেই পারছি না, এত ভয়েস ব্রেক করছে। মাই ভয়েস ইজ ক্লিয়ার টু এভরিওয়ান? প্রবলেম হচ্ছে কিনা সেটাই বুঝতে পারছি।
Yes ma'am, yes ma'am.
এই অবধি বোঝা গেছে?
খারাপ তো তাই।
হ্যাঁ প্রচন্ড খুবই বাজে অবস্থা, ওই জন্যই সমস্যা হচ্ছে। So in the same way you will take the input for B array for the second polynomial. So for the first polynomial and for the second polynomial you have taken this input. So input taking is done means the polynomial creation has been done. When the polynomial creation will be done, after that you have to perform the addition part. আমি অ্যাডিশনের প্রোগ্রামটা পুরোটা বলছি না, আমি জাস্ট লজিকটা বলে দিচ্ছি what will be the concept of addition part. For that part what you are going to do, you are going to conceptটা হচ্ছে you have to take two variables. What is that concept? The concept is you have to take two variables. কিরকম? Initially m will be m and n or any other two variables, q, anything you can take. M is equals to 0 and n is equals to 0. These two you have to take initially. Why these variables are required, I will tell you the example. এটাকে যদি তার মানে আমি আগে অ্যারে দিয়ে রিপ্রেজেন্টেশনটা দেখাই। If we are going to do this part using array, the concept is three, 4 here, 0, 3 here, 5, 2 here, 0, 1 and here 2, 0. This is the polynomial. Why? Because this is coefficient, this is exponent. Next term is not present, that's why the coefficient value is 0. This is exponent 5x square. Here x to the power 1 part is not there, that's why this part is 0, this is 1, this is 2, this is 0 for this part 2. Similarly you are going to represent next part. So in that way the polynomials has been represented using this array. আমি পুরোটা এখন আজকে দেখাচ্ছি না। After that, what is the concept of this m and n? The concept of this m and n will signify, or দুটো দরকার নেই, একটা নিয়েই হবে যেহেতু 1D array. It will signify the indexes of the resultant array. যে resultant array C যা তৈরি হবে, this is A, this is B and this is C, that is the resultant array. That means this thing. When this thing will be created, you have to find out when this thing will be created, then what you have to do? You have to go for this part and for this part. যেমন ধর এরকম তো হতেই পারে, প্রথমে এটা থেকে স্টার্ট করলি, এটা থেকেও স্টার্ট করলি, তুই দুটোর কম্পেয়ার করবি। Exponent by exponent will be compared. If they are not equal, then what you have to do, you have to find out which one is larger. কেন লার্জারটা দেখছি, ধর এখানে 2x to the power 5 is larger than 3x to the power 4 according to the power. তাহলে এইটা আমি দেখছি কেন লার্জারটা, কারণ লার্জারটার আর এর সাথে ইকুয়াল হওয়ার কোনো চান্সেস নেই। টু দি পাওয়ার 4টা পরে এখানে কোথাও থাকতে পারে, it may be possible that it is present to the right hand side, but x to the power 5 cannot be present in P1 anymore because it has been represented by the descending order of degree. So that's why first we will compare this exponent with this exponent. If these two exponents are equal, তাহলে আমার কোনো প্রবলেম নেই, we will add the coefficient values. But if those exponents are not equal, then what we have to do, we have to check that which one is greater. Which one is greater? According to that, which one is greater? According to that, this part will be added in C. যেটা বড় সেটার কোনো চান্সেস নেই পরে, যেহেতু আমি ডিসেন্ডিং অর্ডার অফ ডিগ্রিতে সাজিয়েছি, সেটা আমি সিম্পলি এখানে বসিয়ে দেবো 2x to the power 5 means 2 and 5. Simply we will copy that in C. এবার নেক্সট, আর যেই এটা কপি হয়ে যাবে, we will shift this value to 1. Now this is the part. এবার এটার সাথে এটার কম্পেয়ার হবে। কেন? কারণ হতেই পারে এখানে x to the power 2 এর জায়গায় x to the power 4 আছে, তাহলে তো আবার ইকুয়াল হবে। So that's why we have shifted this part, but this will remain in the same position. Compare হলো কোনটা larger, this one is larger, তাহলে এটা বসে গেল। 3 and 4 will be put over there. যেই 3 আর 4 বসে গেল, সঙ্গে সঙ্গে এটাও শিফট করবে, যেটা বসে সেইটা শিফট করবে। So here 5x to the power 2, 3x to the power 2, so same coefficient, so 5 plus 8, 5 plus 3 8 and 2 will be there. তাহলে দুটোই শিফট করবে যেহেতু দুটো অ্যাড হয়েছে। এবার এটা আর এটার কম্পেয়ার হবে, this one is larger because it has containing 1 and this is containing 0, so 9 and 1 আগে বসলো, next 2 and 0. So in that way the addition operation between the two polynomials will be executed. You are going to compare element by element, that means this with this, but may be possible after this x to the power 4 can be present. আমি জানি না আছে কিনা, তাহলে আমি তো এটাকে শিফট করিয়ে দিতে পারবো না, কারণ এটাকে যদি আমি শিফট করিয়ে দিই এই পার্টিকুলার এলিমেন্টে বা এই পার্টিকুলার টার্মে চলে যায়, তাহলে তো এটার সাথে আবার পরে যদি x to the power 4 থাকে অ্যাড হবে না, শুধু এটাকে নিয়ে তুললাম, তারপর এটা এখানেই থাকলো, এটা আর এটার কম্পেয়ার করলাম, দেখলাম যে এটা বড়, তাহলে আমি এটাকে এখানে তুলে দিলাম, তারপর এটাকে শিফট করি, এটা এটার কম্পেয়ার করলাম, এটাকে কিন্তু আর শিফট করালাম না, যেহেতু এটা তুলেছি এটাকে শুধু শিফট করালাম। So in that way, ultimately the polynomial addition is going to be taken. In the next class, again from the beginning, we will start the total code, just the logic part I gave you in today's class. In the next class, we will go for the total code. Okay?
ম্যাম ওখানে স্ট্রাক্ট পলিটা কেন লিখেছেন?
স্ট্রাক্ট পলিটা লিখেছি কারণ আমার পলিনোমিয়াল ছাড়া একটা অ্যারের মধ্যে দুটো করে ভ্যালু কি রাখা যায়, এই জিনিসটা কি করা যেত যদি আমি স্ট্রাকচার না করতাম? একটা অ্যারের একটা ইন্ডেক্সে ভ্যালু রাখা যায় নরমালি অ্যারে হলে, সিম্পল অ্যারে হলে। এবার যেহেতু এখানে কোএফিসিয়েন্ট আর এক্সপোনেন্ট দুটো করে টার্ম আছে, সেজন্য আমাকে একটা স্ট্রাকচার নিতে হলো। উইদাউট স্ট্রাকচার তো আমি এটা করতে পারবো না, সো উই নিড দ্য হেল্প অফ আ স্ট্রাকচার। তাই জন্য আমি স্ট্রাক্ট পলিটা লিখেছি। আমি নেক্সট দিন দরকার হলে আরেকবার বলে দেবো।